So notes 3A, the uses and abuses of percentages. Since this is a longer section, it may take 2 videos to hit the highlights, but I'll do my best to get it as condensed as possible. The first piece here, looking at a quick review of percentages, remember percents just means per 100 or divided by 100. A percent can be written as a fraction or a decimal. So for example, 17% written as a fraction, you always put your percent over 100. You reduce it if you have to. That's the only part I want to talk about more about up here. And then if you want to get it to a decimal, just type 17 divided by 100 in your calculator. It'll give you obviously 0.17. I just wanted to point out a calculator button though for this first piece here. To convert a percentage to a fraction, like I said before, you just take that percentage that you're given, in this case 35, put it over 100. Well, of course, that can be reduced. And some of you might be really good at doing that by hand. However, just thought I'd let you know calculator buttons. If you do reduce it by hand, then you are dividing them both by 5. And so 35 divided by 5 is going to give you 7. And 100 divided by 5 is going to give you 20. Calculator buttons, though, to work through something like that, you would just type in your calculator, whatever kind of calculator you have, 35 divided by 100, hit enter. You're going to get 0.35 at that point. For those of you with the larger calculators like the TI-83, TI-84, you're going to hit the math button, which is underneath your green alpha key, hit math, and then hit enter, enter. And then those of you with the smaller TI-30 calculators, your button is, after you've typed in 35 divided by 100 and you've got your decimal as 0.35, you're going to hit second PRB. And PRB is one key to the right and down of the second key. And then hit enter, or your equals mark, okay? And then you'll also get your answer. If you have any calculator questions, always, feel free to call me or email me, and I'll be happy to do it. Sometimes, though, since calculators can vary, you may end up having to stop by or something like that to let me figure out your buttons for you. I'm going to scoot on down. I think the rest of this is pretty self-explanatory up here at the top. Let's scoot on down here to our next formula. Any formula that I talk about here in this section are located for you on the formula sheet, so you don't have to memorize anything. First formula, though, that you see here is part equals percent times whole. It's really important that when you are solving for the percent that you always multiply by 100 to get your answer. Otherwise, though, if you're solving for part or whole, your equation is just going to give you your answer outright. But if you are solving for the percent, you'll always multiply by 100 to get your answer. So I'm going to do part A of example 1 and then move on from there. Here we're looking at a serving of double stuffed Oreos. They only allow you 2 cookies. Each of those servings gives you 140 calories, 7 grams of fat, and so on. It's like reading the ingredient label, or the nutrition label, I should say. A woman, though, who's 19 to 30 years old and moderately active is allowed up to 2,200 calories in a day. So in part A, we want to know, well, if the woman in this age range eats 1 serving of those Oreos, what percentage of her calories has she already consumed? So I'm going to use my formula here. Part equals percent times whole. And since the problem is asking you for the percentage, then you don't know that percentage, so I'm going to put an X underneath the percentage. And then you think about, okay, well, the part then is the amount of calories that's been consumed with eating the Oreos themselves, and in this case it'd be 140 calories out of the whole amount of calories allotted, 2,200. So the Oreos give you 140 calories out of your total amount allotted, 2,200. And then our ultimate goal here is we want to solve for X. Don't remember how familiar you are with solving equations, but your goal is to get letters on one side, numbers on the other. In a case like this, since you're trying to solve for X, this is X times 2,200. To undo multiplication, you divide. You always divide by the number beside your letter. So the number right here beside my letter is 2,200. So I'm going to divide both sides by 2,200. Doing that over there on the right-hand side, they cancel out, just leaving you with X. And then over here you do 140 divided by 2,200 and you get 0.0636. And then, like I said above, when you're trying to solve for the percentage, you multiply by 100, and then that's going to give you 6.36%. So 6.36% of her calories then have been consumed by eating those 2 Oreos. Okay? We'll move on down to our next set of formulas, which are reference to absolute and relative change. You'll be using these quite a bit, and actually later on in the course, I'll reference these formulas several times. But nonetheless, you'll always have these formulas. Absolute change is just a simple new amount minus old amount. Relative change is the absolute change divided by the old amount. And absolute change, as you see above, is just your new minus your old divided by your old. If you're going to type this in your calculator all at one time, it's important that you put the top here in parentheses. But otherwise, you could just type the top, hit enter, then divide by the old, and then multiply times 100. Your book uses other terminology as opposed to new and old amount. I found that new and old amount is a lot easier to reference. So I have manipulated that formula from the book. Relative change can be a percent decrease, which in terms then it would be a negative value, or it could be a percent increase, making it a positive value. So let's flip it over so you can see what one of those look like. It's here in example 2. This happens quite often. You got your cable bill premium is increasing. It says the bill is changing from $58 a month to $67 per month. We want to find the absolute change and the relative change, and then we're also going to write a sentence to put it in context. I probably won't write it. I'm going to verbally say it. Absolute change here, as you saw on the previous page, your formula is your new amount minus your old amount. So our new amount of our bill is $67 minus our old bill amount, which was $58. After I do that subtraction, $9 would be my absolute change, and what that means is that my cable bill has increased by $9 per month. Okay. To find my relative change, remember that formula, new minus old divided by the old. Since I'm trying to find a percentage, I'll multiply by 100. So here, I'm looking at my new amount, 67, minus my old amount, divided by that old amount. Again, if you can do it all at one time in your calculator, be sure you use parentheses. Me personally, though, I like to just go ahead and subtract. So I have 9 divided by 58, and then I just type that in my calculator, 9 divided by 58 times 100. And that should give you 15, rounded to one decimal place, so 15.5%. So what that means here then is that my cable bill is experiencing a 15.5% increase in premium. Okay. Example 3, I'll let you try that. It's very similar. Important things to remember: when a quantity doubles in value, its relative change, its relative percentage change then is a 100% increase. When it triples in value, we're talking about a 200% increase. Quadrupling, 300%. You're probably starting to see the pattern here. And then if a quantity halves in value, the relative change is a negative 50%. I'll go through one of these just to, you might be saying, well, I don't know why if it's doubling it's not 200%. I'm going to go through example 4 here just to show you, here, for example, this example is doubling. It's going from drinking 32 ounces of water in a day to 64 ounces in a day. It says find the relative change. Well, according to the rules that I've just shown you, that's supposed to be a 100% increase. So let's do the math behind it and make sure that it is 100%. Relative change then, formula, new minus old divided by old. So my new amount, 64, minus my old amount, 32, divided by my old amount. 64 to minus 32, of course, is 32. Divided by 32. Well, any number divided by itself is just 1. You're trying to find a percentage, and part of the formula was to multiply by 100. So 1 times 100 is 100%. So for problems like this, you can either choose to memorize these pieces up here, because again, if a quantity ever doubles, triples, or quadruples, these will always be the relative change amounts. So for example, if you were to see example 5 on a test or a quiz, and you say, oh, it's going from, you're going from running 5 miles a day to 15 miles a day, oh, that's a triple in value. I know if you triple, then we're talking about a 200% increase. You could simply write 200%, or you could do like I showed in the previous example here in example 4, and show me the work behind it, actually find the relative change using the formula, whatever you feel more comfortable with. Okay. Let's see, I'm going to scoot on down here to of versus more than. If you want to take a percentage that's already written as percent more than and convert it to percent of, you always add 100%. If you want to take percent less than and convert it to percent of, you subtract from 100%. So here's what I mean by that. So in example 7, it says Ben earns 30% more than his wife. How does Ben's income compare to his wife's income? If he earns 30% more than his wife, then more than to percent of, we add 100%. So I'm going to say 100 plus 30, and we're going to say, okay, well that's 130%, meaning here that he makes 130% of his wife's salary. Okay. In example 8, a store has a 25% off sale. How does the item's sale price compare to its original price? So since I'm going from taking something off here, I'm going to do 100 minus 25, which of course is going to give me 75%. And what I'm saying here is that you end up paying 75% of the original price when you have your new sale price here. Okay. We'll skip on over to our next page. I'm going to look down here at these percentage points versus percent. What's the difference between those two? When a change or difference is expressed in percentage points, it refers to an absolute change, so just a new amount minus an old amount. However, whenever you are given a percent sign or the word percent, it's referring to that relative change where you do the new minus the old, then you divide it by the old, then you multiply it times 100. You're actually getting a percentage. So to sort of see what I mean by that, in example 10, percentage of single-parent households in the U.S. increased from 12% in 1970 to 30% in 1995. I want to find my absolute change. So absolute change is just new minus old. So looking here for our problem, the new amount of single-parent households is 30%, minus the old amount, 12%. 30 minus 12 then is 18. We can say then the absolute change is an increase then of 18 percentage points. If I want my relative change, same formula for relative change, new minus old. So I'm just going to go ahead and put in our numbers now. 30 minus 12 divided by my old amount, which is 12. And then I have 18 up top divided by 12. I'm going to multiply by 100, and that is going to give me 150%. Meaning of that then is from 1970 to 1995, the single-parent households in the U.S. has increased by 150%. And if you think about it, that 150% should make sense, because if you think about it, that we started out going from 12% to 30%. So, referencing back what we talked about on the previous page, if we had doubled, we would have gone from 12 to 24%. And by doubling, then you're talking about a 100% relative change. Tripling would have gone from 12 to 36%, and so tripling is a 200% increase, relatively speaking. So then we can definitely see them, well, I more than doubled, but I didn't quite triple, so therefore my percentage should lie somewhere between 100 and 200%, and sure enough it did at 150%. All right, I'm going to stop here and pick up with a new video for the remainder of this section.